All right, so in this video, we're going to talk about how to solve quadratic equations by factoring. Before I get into it, I just wanted to explain a little bit of like what the purpose of this is. I'm going to start with talking about the principle of zero products. So that's just if I had 7x equals 0, we can imply that, oh, x is 0, right? Because otherwise, like, there's nothing else that we can multiply 7 by to get to 0. But if I had x times 2x minus 9 equals 0, then the principle of zero product says either x equals 0 or 2x minus 9 equals 0, or both. So that's kind of the whole purpose of what we're doing here when we try to solve for like these quadratic equations, solving for zeros and that kind of deal, because we're just trying to figure out what values do we plug in here that will make this 0. So I just kind of wanted to discuss that a bit before going into it. So I'm just going to go with a very small example. If I were asked to solve x plus 3 times x minus 2 equals 0, this is the same thing as saying x plus 3 equals 0, x minus 2 equals 0, and I just solve. So subtract 3, add 2. So I have x equals negative 3, x equals 2. And these are my solutions. And I guess I should probably explain real quick what I did here was, yeah, so just like what I talked about in the zero products property or whatever, I just set each thing pretty much equal to 0, and then I solve, right? Because it's the idea that either of these could be 0. So that's why I end up having two solutions, because, if I plug in either of these, I will get 0. So let's do another one here. If I had 5x plus 1 times x minus 7 equals 0, so again, either 5x plus 1 is 0 or x minus 7 equals 0. Either way, I need to solve for both. So subtract 1, I get 5x is equal to negative 1, divide by 5. I have x is equal to negative 1 over 5. And then here I have plus 7. So I have x equals 7. So these two are my solutions here. Let's do x times 2x minus 9 equals 0. So again, just setting everything equal to 0. So like x equals 0, 2x minus 9 equals 0. X equals 0, we can just leave that be. And I have 2x is equal to 9, divided by 2, and I get x equals 9 over 2, and I can also write that x is equal to 0. So these two are my solutions. Okay, but just like what the title was earlier was using factoring, so we're not lucky enough to have it already factored for us, so you need to do that first. So I have this quadratic, and again, I'm gonna figure out, okay, what two numbers add up to make 5 and multiply to 6. In this case, that's 2 and 3. So I have x plus 2, x plus 3, and then I need to solve. So x plus 2 equals 0, x plus 3 equals 0. Subtract 2, and I get x equals negative 2. Oops, subtract 3, and I have x equals negative 3. So these are my solutions. Okay. Solve x squared minus 8x equals negative 16. So you can see this as, this is a quadratic, right? I need to move everything to one side always. I can't just solve it like this. There's just no way for you to get your x's by itself here. So I must add 6 to the other side to get 0. And being mindful that this only works when it's equal to 0. So don't try to like move things over to the other side. Make sure it's equal to 0, okay? That's very, very important. So here, I'm just going to factor two numbers that add up to -8, two numbers that multiply to 4, or sorry, multiply to 16. The two numbers are -4. Yeah. So I have x minus 4, x minus 4. In this case, like, it's honestly just going to be x minus 4 equals 0 plus 4, and I get x equals 4 for my solution. I don't need to do it twice if it's like, if both of them are the same, so I can just say x equals 4. Okay, let's try x squared plus 5x equals 0. So first, looking at both of these, I can take out an x, and I have x plus 5 equals 0. Then I can do x equals 0, x plus 5 equals 0, subtract 5, and I have x equals -5. So these two are my solutions for this quadratic. All right. So next example. Okay, 4x squared equals 25. Okay, so what we can do here is, well, subtract 25, because like I said, I want to make sure that everything's onto one side and it's all equal to 0. So here, unfortunately, I can't really factor anything out. But if you notice, this is an example of a difference of squares. So if you saw the video about difference of squares, you would know that I can write 4x squared as 2x squared minus 25 can be written as 5 squared. And using the difference of squares rule, I can have 2x plus 5 and 2x minus 5 equals 0. And then I can just solve. So 2x plus 5 is equal to 0. 2x minus 5 is equal to 0. And solve. So I have x equals -5/2 for this part, and then x equals 5/2 for the second one. Okay. All right. So -5x squared plus 2x plus 3. So, right. I think what we can do here is, well, first, I can at least take out a negative. But other than that, I can't really take out any numbers here. So I'll just say negative on the outside, 5x squared plus 2x plus 3 equals 0. And honestly, this negative can kind of go away, because if I divide both sides by -1, what happens is I just get 5x squared plus 2x plus 3 equals 0. So that's really nice. Oh wait, I just realized I did this wrong. I forgot to make these negative because I took out a negative. So the other signs flip. My bad. All right, so now I can't take anything out of these, and I have a number in front of the x squared, so we're gonna have to use AC method. So I'm gonna do 5 times -3, which is -15. Two numbers that add up to -2, numbers that multiply to -15. So let's see, 15, 1 and 15. no, 3 and 5. Oh yeah, 3 and 5. Okay. 3 and I think minus 5. Yeah, 3 and negative 5. So I'm going to rewrite this to get 5x squared. I'll probably write it on this side. 5x squared minus, plus 3x minus 5x minus 3 equals 2, or sorry, equals 0. Factor by grouping, so looking at the first two terms, I can just take out an x, and I get 5x plus 3. Here I can take out a negative 1, and I have 5x plus 3 equals 0. So I'll have 5x plus 3 and x minus 1 equals 0. Fortunately, we're not done yet because we have to solve for these. So 5x plus 3 equals 0, x minus 1, oops. X minus 1 equals 0. Solve. And I get x equals negative 3 fifths. If I add 1 to both sides, I get x equals 1. So these two are my solutions here. Okay, and then there's another one. Yeah, this is the last one I want to talk about. But this one's deceiving. Now this part, I'm going to write, don't do this. Don't say, oh, x plus 2 equals 5, x minus 2 equals 5, and then try to solve. This is not it. This is not the way to do it. Like I said before, this must equal 0 on the other end in order for us to solve. So what we have to do is we have to subtract 5 on both sides. So I have x plus 2, x minus 2 minus 5 is equal to 0. Okay. And what we'll have to do is we're going to have to FOIL this out. And then we'll factor because I can't break it apart when I have a minus 5 there. It just doesn't work. They all have to be like being multiplied together. So I need a first FOIL. So I get x squared minus 2x plus 2x and then minus 4 minus 5. So the 2x's cancel, so I get x squared minus 4, or actually, sorry, I could speed up this process. So the 2x's cancel. Negative 4 minus 5 is minus 9. And as we know with difference of squares, I can write this as x squared minus 3 squared. And so using difference of squares, I can have x plus 3 and x minus 3 equals 0. X plus 3 equals 0, x minus 3 equals 0. So if I kind of move this along, I get x equals 3 and x equals negative 3 for my solutions.